All right. I said since there's a chance that there will be a snow day tomorrow, to help us continue to move through and you guys continue to learn, I said I'll do one or two problems to kind of help you guys out to move through the rest of this part of the physics packet. Okay? So let's take a look at page in the current packet this year. It's on page 67. It's under the coefficient of friction problems. So the problem is this. The Ford coupe, right? There's a coefficient of friction between the Ford coupe and the dry pavement. So the coefficient of kinetic friction, because we're going to see that this car is going to be moving against the ground. So the mu of k is going to be 0.85. We see that we have to solve for the acceleration, and I'm assuming that's acceleration in the x direction because we're moving horizontally. We have that the mass is 1,300 kilograms, and it's skidding to a stop. So make a note of that. That's going to be important. So here's our box over here where we list our givens. Now the next part in higher level physics, being able to draw a picture, a free body diagram. So there's the box right there, 1,300 kilograms. Put that in there because that is mass. Let me make sure this is showing up on the camera. I'll zoom in a bit. Okay. So right off the bat, I can't get acceleration yet, but I can do other things to help unlock different variables. So right now I say I have 1,300 kilograms. Given that, I can look at my y forces because they might be important when it comes to friction. Notice that we have the mu up here. So let's find force of gravity first. So we go in this box down here, formula, W equals mg. W equals the mass of 1,300 kilograms times 10 meters per second squared, acceleration due to gravity on Earth. Weight is going to be 13,000 newtons. So we have 13,000 newtons is the force of gravity. So now our force of gravity is 13,000 newtons. And since we have no acceleration in the y direction, acceleration in y is 0, therefore we know that the forces are balanced. So our normal force is going to be 13,000 newtons. So the weight is 13,000, so we know that the force of gravity equals the normal force in this case. Let me double check that it's showing up on the camera. Okay, it looks all right. All right, good. Let me move this over a little bit. Okay. So now I got a normal force, I got a force of gravity. I have a mass, I have a mu. I need to find acceleration, and I need to find, it looks like friction. So we see that the car is skidding. And it's also, we're going to assume moving rightward. So there's the velocity vector moving rightward. So if it's skidding, the only force acting upon it is friction in the leftward direction. There's no applied force to push it forward. They're not hitting the gas. It's coasting. So it's going to be friction is the unbalanced force, and that's going to be the net force. Okay? So the next step to figure things out, we're going to open up another box over here where we solve for the force of friction. So what formula do we all know that relates kinetic friction in this problem? It's going to be mu, the type of surface, and the normal force, how hard they're pressing. So it's going to be the force of friction equals coefficient of kinetic friction times the normal force. So now to get the force of friction, we take our mu value of 0.85, which does not have a unit, although period 7, I like your idea about a unit of Newton, but it doesn't really have a unit, but nice job. And our normal force is 13,000 newtons. And real quick, what you should be thinking is this. It says here, it's a dry pavement. What if this was a wet pavement? Could that value change? Absolutely it could. How could it change? It would decrease. Because if this decreased, this value would be lower. You see how that works? So type of surface, how hard they're pushing. Not only when you do these problems, you see there's a lot of conceptual thinking that has to occur. And that conceptual thinking, that ability to do that comes with your studying and reading and practice. And look how fun it becomes when you do it. So our force of friction in this case is going to be, I put it right here, 11,050 newtons. So now that's the force of friction. So now we know that is the net force. And it's going in the leftward direction. Okay. So now, that is taken care of. Are we done? We now know the force of friction, 11,050 newtons. Are we done? No, we still need to solve for acceleration in the x direction. So we know it's accelerating because the forces are unbalanced. Acceleration, unbalanced, speed up, slow down, friction, because it's going this way. We have a leftward acceleration while the car is moving rightward in its velocity, slowing down. Okay? Every time, there's got to be a mass inertia. So we use our second law. Net force in the x direction equals the object's mass times acceleration. Net force equals a mass of 1,300 kilograms. And if this isn't showing up, give me a minute. I'll move it up so you can see it. One-man production here. 1,300 kilograms times an acceleration. Oh! We don't have acceleration. Uh-oh. What do I do? Think. Right here. We have the net force. So we got to solve for acceleration. So we solve for m on both sides. See what happened right there? I got so into my song, I was thinking about something else, I lost my focus. You know, I'm not going to edit it out, I really don't care. It's fine. So we got to solve for acceleration, so we take our net force in x, which is 11,050 newtons, divided by a mass of 1,300 kilograms, equals A. And the answer to that is, okay, I'm losing room, 8.5 meters per second squared leftward. So the acceleration is going to be 8.5 meters per second squared going left, or you could say negative, assuming that this value is negative. So the acceleration is going to be 8.5 meters per second squared going to the left, or you could write negative. Either way, because it's a negative direction force. All right? So all of that, and what did we start off with? We were given 1, 2, 3 pieces of information. Coefficient of kinetic friction and mass. And we knew the object was skidding. The skidding told us that there's no applied force, it's only in the opposite direction as friction. See how a couple little pieces of information open up a lot. Well, how do you know to unlock all of this? Through your studying and understanding of the concepts of the Newton's laws. Okay? All right, so next one. Now here's the funny part. There's going to be a fire drill in 5 minutes. That's also my mind. Whoop. So now I'm rushing. I'm trying to get this done. Because there's a fire drill in 5 minutes. So I better hurry up before the fire drill occurs. Okay. Go to page 69. It's the vertical thrust problem, the Harrier jump jet. Okay. So you can read the problem. I got to move a little faster. So again, this is the last part of level 7. So hopefully this will help you. So it says, what's the vertical thrust required to accelerate? Oh, a mass, 8,600 kilograms. Acceleration upward, keep that in mind, 0.4 meters per second squared. Okay, so now you have those two givens. That's all you have. We need to solve for the vertical thrust, the force of thrust upward. So to me it looks like our x forces aren't coming into play here. We don't need to worry about our horizontal forces. So where do we always start with this problem? With all these problems? In physics, draw a free body diagram. Again, when you get to AP physics, dude, I'm sure they're going to be a lot more complicated than this. But when you see that complicated problem, if you study hard and you understand, hold on, let's draw it. Uh-oh. Don't start it yet, wait! 86,000 newtons is the force of gravity. W equals mg. W equals the mass. Don't, no, hold on. 8,600 kilograms.
Not here yet.
Good, times 10 meters per second
Fire
squared.
drill right now.
No, there won't. So we have 86,000
Do a quick fire drill over
newtons.
a
No!
building.
86,000 newtons. Now that's the downward force. Now we got to figure out the thrust force, but I can get this. I have weight. I can now also find here the net force. So check this out. So over here I'm going to go. Don't listen to him. We'll go out in a second. Mass times acceleration. Net force in the y direction. Can I make it? Mass 8,600 kilograms. Oh no! Dude, this is riveting television. Here we go. What's the acceleration? 0.4 meters per second squared. Thank goodness I have the answer key. Net force in the y direction. No! 3440 newtons. So that's the net force is 3440 newtons. How do I get the thrust force? Add them up. Guess what the answer is? What is it? 89,040. Upwards. It's going up. It's speeding up, going up. Therefore, it's accelerating in that direction. Dude, this is going to be the highest rated video ever in the history of Spring for 8th grade Center on Demand. There's the answer. I gotta go. Bye.